All right, so, whoops, got to go to screen share. All right, I'm just going to go ahead and walk through these. So the first one is, let me just move things, let me do a little bit of bookkeeping here as far as space goes. All right, so the first one, we want a mass of sodium iodide to make 500 mils of a 0.500 molar solution. So the idea here is anytime that you have two numbers, it's not necessarily obvious where to start. So we want the answer to be in grams of sodium iodide. And if you look here, we don't have grams anywhere, but we can always get grams from the molar mass. So the molar mass of sodium iodide is 149.89. So there's 149.89 grams of NaI in a mole of NaI. And so now we need to get rid of moles, right? So remember, you can always get mass, right, from molar mass. You can always use Avogadro's number. But here, the only other place we have moles is in the molarity. So it's a good habit for your problem solving to just get used to writing molarity as moles per liter. So the problem says that there's 0.500 moles of NaI per liter. And now we just need to make liters cancel. Well, we have 500 mils, 0.500, and those zeros are all significant. And so that's it. Molarity times volume to moles times 0.5 times 0.5 is, and this will have three significant figures, 37.5. By the way, on the exam, by and large, people were very good on significant figures. So as a whole, really nice job. All right, number two, again, you have two numbers to start the problem, so it's not obvious where to start. So that habit of always writing the units of the answer. We want volume, and we know molarity has liters in it, so let's go for liters. And since we chose liters, we know we're going to use the molarity, but we're going to flip it over. 1 liter is 0.0250 moles of ammonia. Now, to make moles go away, we can use molar mass or we can use Avogadro's number. Which one should we use? Well, because we have molecules, we should use Avogadro's number. So you see how you want to get comfortable, and you've done a lot of problem solving now with going backwards, going forwards, just putting the units where they need to go to make the problem work. So now I have the molecules. I need molecules in the denominator, and I know that Avogadro's number. Per mole. And then when I do the math here, is 528 liters. And remember that old, does my answer make sense? It sounds like a lot, but you've got 10 to the 24th molecules. So it is a lot. All right, number 3, same idea, 2 numbers to start. So let's go, we want K ions. So the answer is going to be K ions. Just, we can write K plus if you want. And we don't have K, but we do know we can get ions. An ion is a particle. I can use Avogadro's number here. That's a decimal point. I'm just going to write K plus per moles of K plus. I can use ions if I want. Now the problem is I don't have anything about K, but I have moles. But what else can I do with moles? Well, I can get to moles of potassium phosphate. So let's do that. Just move this over a little bit. 0.2250 liters, actually that didn't help moving it over, times 0.200 moles, that's K3PO4. So you're stuck going backwards, so let's just play with it going forward. And now it almost screams at me, what unit do I need? I need moles of K plus per mole of K3PO4. And you've done stuff like this. You did this back on exam 2 and homework 4. We know that there's 3 moles of K per mole of K3PO4. And so this one, 0.225 times 0.2, let's make sure I didn't make a mistake, times 3 times Avogadro's number. So this is going to be 3 significant figures, 8.13 times 10 to the 22. Let's move this over here out of the way. All right, I want to make sure I'm not going too fast. So again, you know, you literally, I know I say just play with it, but just get a unit that you want in the right place. And then we didn't know what to do here. We had K ions and we don't have anything about K. So what else do we know? Well, we know we can always get to moles. And if you're in doubt, get to moles. And then if you get to moles, then it kind of told you what to do next. All right, number 4.
Is that 8.13?
That's what I got, yeah. Did I push a button wrong?
No, I was just confirming, just to make
Okay.
sure.
All right. Okay, number 4 says if you dilute, okay, this is a dilution, it says so. I'm going to dilute 5 mils of 10 molar HCl to 2.50 liters. What's the new molarity? I'm going to do this one with dimensional analysis. I'll do the next one, which is also a dilution. I'll do the next one with the equation just to vary it up a little bit. So we want to find the new molarity. We want to find moles of HCl per new liters if you want. So we want for number 4, we want moles of HCl per liter, let's just say of the dilute solution. All right, now we can get moles of HCl here. We have 0.00500 liters of the concentrated solution. And we have 10 moles per liter. So the 5 mils and the 10 molar are the same solution. The 250 is the second solution. So I don't care how you label this liter, but you want to make sure that you label this liter in one way and label the other volume differently, just so you can tell them apart. The students all the time, I did it myself when I was learning this, is I would switch the volumes. So then we have moles of HCl. We just want liters of that diluted solution, and it's 2.5, and we're just going to put it in the bottom. Whoops, and see what I just did? I did that to show you how easy it is to drop a decimal. 2.50. You know, and the subscripts are really for you internally. Let me just move this over a little bit. You know, when you're all done, you don't have to write liters of the dilute. So my new molarity is 0.0200. All right, there's your first 4. I'm going to erase numbers 1, 2. Let me make this smaller again. I'll erase the first 2 for a minute here. So keep them up here for you. Whoops. All right, so let's go to number 5. So number 5 says describe how to make. So this is another working backwards. So when you're making a solution, all right, I'm going to turn off the screen share for just a second. You want to think in terms of it's describing, where's my pen? There it is. If I'm making a solution, so here's one solution, here's my stock solution, and I'm going to make a new solution out of it. What I'm going to do is I'm going to take some of the liquid out of the stock and I'm going to put it into the new one. And so what I have to figure out is what volume of liquid or what volume of the solution take out of here to put into here. And then I'm just going to bring the volume up to whatever the final volume is. And we have glassware in chemistry that is labeled, so you don't have to figure out how much to add. You just fill it up to the line. So if I'm going to fill it up to, if I'm going to make 250 mils, I'm just going to dilute it to 250 mils. So in the interest of the think backwardsing, when I say describe, I want more than just the number, all right? I want you to say, so what I'm going to do is I'm going to dilute a certain number of mils. You can put it in liters if you want, but I'll just do it in milliliters. Milliliters of the stock solution to, what is it, 250. So now all I have to do is figure out that volume. All right, so let me create a little bit more space here. Let's erase number 3. I'm going to do this one with the formula, just so you have an example of each way. You can do this with dimensional analysis if you prefer. If you're going to use the formula, you want to make a list. MC equals VC. And again, I use C and D. You can use any subscripts you like. Right? I started using descriptive subscripts when I was in college because I found it was less confusing for me. But that's me, all right? So I'm going to make 250 mils of the 0.2. So my dilute is 250 mils. And it really doesn't matter which one's which, but the 250 and the 0.2 are the same solution. So if you call your molarities 1 and 2, you call these 1 and 2, you can put them both there, it doesn't matter. And I'm making it from a 6 molar solution. And so I want to find the volume. So then I use my formula. I want the volume of the concentrated, so this is the algebraic part of our show. I want the molarity of the concentrated. And then I plug in the numbers, so I have 0.200 molar, 250 milliliters over 6. What's nice about you still want to use units, because if the volumes say we're in different units, you definitely would have to do a conversion. In this case, though, so now I just do the math. In this case, it comes out in milliliters. I could have put them all in liters if I wanted. But you definitely want the right units. So I get 8.33. And again, if I say describe, if you just write 8.33 mils, you're not going to get full credit. You don't have to write a paragraph, just something like I'm going to dilute. Think like if someone asked you, how do you do this? You wouldn't go 8.33 mils. You'd give them a little bit of, you'd say dilute 8.33 mils to 250. All right. So we did one with dimensional analysis, one dilution using the formula. Again, it doesn't matter. You can do it either way. But even if you're using the formula, you want to use units, because if I gave you a problem where one unit was, let's say one volume was in liters and one was in mils, if you don't put the units in, you won't catch that. So you want to make sure your units work. All right, let's look at number 6. Number 6 says, okay, we're going to react. So what volume of HCl is necessary to react with magnesium metal? So that means Again, if you're told about one thing and asked about another, you need a relationship between them. And so it's reacting with, so we should write the reaction, Mg plus HCl. So you guys did very well on the test on the reactions part. Nice job. So this is a single replacement. It'll be MgCl2 and H2. And if you're not sure how to do this, you want to review how to come up with these things, because this is, you can see exam 4 is going to have this kind of stuff on there. So you definitely don't want to forget about it. And I do have office hours. I had a couple students came by office hours and did much better on this exam than a previous one, so it worked. All right, so now we want to find the volume of HCl. So let's go with liters. I'll just put liters of HCl here. And actually we're told this is 0.500 molar. We want to find volume, and we're told 2 grams. So now it's the same kind of problem solving we've done before. And you can even think in terms of the way we did things with stoichiometry. Textbooks are funny. They classify different kinds of stoichiometry. I would say stoichiometry is stoichiometry. It's just a function of, you're going to, one way or another, you're going to get to moles of something. You're going to use a balanced equation to convert to moles of something else, and then you're going to get out of moles. Different kinds of stoichiometry are different ways of getting to moles and different ways of getting out. Here we're going to use the molar mass because we have grams. So we know 1 mole of magnesium is 24 grams of magnesium. I'm close to the bottom of my page here. All right, we want to get to HCl. We know that there's 2 moles of HCl per mole of magnesium. And now the last step is we want to go from moles to liters, and we have a molarity. So 1 liter of HCl is 0.500 moles of HCl. And so we do the math. Here, I gave myself more time than I need. That's okay. 2 divided by 24.305 times 2 divided by 0.5. So this is going to be 0.329, and again, it's 3 sig figs. All righty. Let's do one more. And then I'll turn off the recording and I can answer questions. Da, 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 da. All right, last one, number 7. Whoops. So number 7, we have, it takes 32.34 milliliters of this molarity of KOH to neutralize, remember neutralizes reacts with a certain amount of sulfuric acid. We want the molarity of the acid. So again, we're told about the KOH, we're asked about the sulfuric acid. So the first thing we're going to need is a balanced chemical equation. So we can write that, the KOH is going to react with the sulfuric acid. And again, you guys have done a lot of this equation stuff, so you should be able to come up with the products. If you're still struggling with that, please, 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 that's what office hours are for. And let's see, I need a 2 here and a 2 here. Then I'm told I have 32.34 milliliters. I have 0.9982 molar. I have 10 mils of this. And I want to find the molarity. All right. All right, so I want my final answer. Again, obviously we can get to moles here. So we'll use this to get to moles, if you like diagramming, right? And then we're going to get to molarity. Unit-wise, my final answer is going to be moles of H2SO4, molarity of H2SO4. And actually, experiment 11, you're going to do stuff like this per liter. And since I have 2 volumes, I'm going to label it liters of H2SO4. Again, you can label it, you can call it liters 2 if you want, but just make sure you don't confuse this volume with this volume. Make sure you know which is which. Very easy to make that mistake. And then right away, I'm going to put the liters of H2SO4 because I know what that is on the bottom. And I remember when I was learning this, I was like, well, how can you just do that? And the answer is that's what dimensional analysis is. So now all we need is to get moles of H2SO4. But I don't have that directly, but I could get moles of it. I don't have the mass. I don't have Avogadro's number. I don't have a number of particles. So the only way to get moles then is to get it from moles of something else. I can get it from, I can get moles of KOH because I have enough information. I have a molarity and a volume. So I have 0.03234 liters of the KOH times 0.9982 moles of the KOH per liter of the KOH. Again, always cancel as you go. So now I have moles of KOH per liter of H2SO4. That's not what I want. I want moles of H2SO4. But I know from the balance of a chemical equation that there's 1 mole of H2SO4 for 2 moles of KOH. And then the units work, moles of H2SO4 per liter of H2SO4. And so now we do the math. So I get 1.614. And you can leave your answer that way, or you can call it 1.614 molar. The capital M is really an abbreviation. All right, I'm going to turn off the screen share. I'm going to stop the recording, but then I'll keep it open for questions at that, and I'll close it in 10 minutes. But let me turn off the recording so your questions aren't recorded. So recording, stop recording.